First of all, his biography. His full name is Abu Abdullah Mohamad ibn Isa Mahani, born in 1860 at Mahan, Persia, and died in 1880 at Baghdad, Iraq. He was a Persian mathematician and astronomer born in Mahan, which known today as Kerman, Iran, and active in Baghdad Abbasid Caliphate.
Next, for his contribution, his only known surviving work on astronomy was on the calculation of azimuth. Azimuth means the direction of a celestial object from the observer, expressed as the angular distance from the north or south point of the horizon to the point at which a vertical circle passing through the object intersects the horizon. You can refer to the picture given. Next, he also known to make astronomical observation and claim his estimates of the start times of 3 consecutive lunar eclipses were accurate to within half an hour. Next, for his life history, Ibn Yunus writes that Al-Mahani observed lunar eclipse and he calculated their beginning with an astrolabe, and that the beginnings of 3 consecutive eclipses were about half an hour later than calculated. According to the Omar Khayyam, Al-Mahani was one of the modern authors who conceived the idea of solving the auxiliary theorem used by Archimedes in the fourth proposition of the second book of his treatise on the sphere and the cylinder algebraically.
Bismillahirrahmanirrahim. Next, I will explain about Al-Mahani works, which is mathematics. His works on mathematics cover the topics of geometry, arithmetic, and algebra. Some of his mathematical work might have been motivated by problems he encountered in astronomy. The 10th century catalogue kitab Al-Fihris mentions Al-Mahani's contribution in mathematics but not those in astronomy. He also worked on current mathematical problems at his time. He wrote commentaries on Greek mathematical works, usually Elementon, Archimedes, and on the sphere and cylinder and analysis of character. In his commentary, he added a explanation, updated the language to use modern terms of his time, and reworked some of the proof. He also wrote a standalone treatise fi al-Nisbah on the relationship and another one on the squaring of parabola. His commentaries on the element cover books 1, 5, 10, and 12. Only those on book 5 and part of those on book 10 and 12 survive today. In the book 5 commentary, he worked on ratio, proposing a theory on the definition of ratio based on continuous fractions that was later discovered independently by Al-Naiziri. In the book 10 commentary, he worked on irrational number, including quadratic irrational number and cubic ones. He explained Euclid's definition of magnitudes, which include only geometrical lines, by adding integers and fractions as rational magnitudes, as well as square and cubic roots. As irrational magnitude, he called square roots plane irrotational and cubic roots solid irrotationals, and classified the sum result of the roots additional or subtracting from rational magnitudes. Also as irregular magnitudes, he then explained book 10 using those rational and irrational magnitudes instead of geometry magnitudes like in the original. His commentary of the Safari covered book 1 and part of the book 2, none of which survive today. His edition was later updated by Ahmad ibn Abi Said al-Huri in 10th century. Later, Nasir ad-Din al-Tusi dismissed Al-Mahani and Al-Kharawi's edition and wrote his own treatment of the Suffolk. Based on the work on Abu Nasir al-Mansur, Al-Tusi edition became the most widely known edition of the spherical in the Arabic-speaking world. Al-Mahani also attempted to solve a problem posed by Archimedes on the sphere and cylinder, book 2, chapter 4, how to divide a sphere by a plane into two volumes of a given ratio. His work led him to an equation known as Al-Mahani equation in the Muslim world, which is x to the power of 3 plus c to the power of 2b equal to cx to the power of 2. However, as documented later by Omar Khayyam, after giving it lengthy meditation, he eventually failed to solve the problem. The problem was then considered unsolved until 10th century. Questions mathematics Abu Ja'far al-Khazini solved it using the conic sections.
Al-Mahani, in his astronomical observation of conjunction as well as solar and lunar eclipses, was cited in the Zich astronomical tables of Ibn Yunus, 950 to 2009. Ibn Yunus quoted Al-Mahani as saying that he calculated the timing with an astrolabe. He claimed his estimates of the times of 3 consecutive lunar eclipses were accurate to within half an hour. He also wrote treatise on the determination of azimuth for an arbitrary time and an arbitrary place. His only known surviving work on astronomy. In it, he provided two geographical methods, an arithmetic and one calculating the azimuth. The angular measurement of heavenly objects' location. The arithmetic method corresponds to the cosine rule and spherical trigonometry, and was later used by Al-Battani